Hi, if you're interested on join to discuss automotive stuffs, you can join in this WhatsApp group. The link will be provided in the description column. Agenda of this tutorial is CAN TP, that is a flow control. We'll start with CAN TP. What are the frames in CAN TP? Request and response frame of flow control, and finally, very brief explanation on flow control. Yes, we'll start with assumption scenario. So from the requirement from the customer says write ECU serial number using write data by identifier, that is of service ID 0 cross 2E. It should be in default session and no security access is required. That is what the assumption scenario from the customer. So not only this, the data to be written, that is the serial number to be written, is use data identifier as 5C and 66. For the serial ECU serial number, the identifier data identifier should be considered as a 5C and 66. That means under 5C and 66 you have to write them data from the for the serial number. So the serial number is, it start with 48 32 6C up to C6. That is around 30 bytes of data to be consumed for writing serial number, ECU serial number, under the data identifier 5C and 66. Now we'll we'll have some brush up on the CAN TP, then we'll come back to the flow control. So CAN TP, that is CAN transport protocol, is nothing but the CAN TP is a standard for sending data packets over a CAN bus. Is in CAN bus you can send messages using by means of a data package. Okay, so the protocol, this protocol, there is the CAN TP is a protocol. This protocol allows for transport of messages that exceeds the 8 byte of the data in the CAN frame. So once the 8 bytes of data have been exceeded, then CAN TP comes into the picture. Not only 8 bytes, you can also consider into the bytes which is less than 8 or 7. But these transfer of messages can be deals using the transport protocol, CAN transport protocol. So each frames can carry up to 4095 bytes of the data. There is 4095 bytes can be in each frame. You can have 4095 data bytes, that is data bytes. So this TP covers the third layer and fourth layer in the ISO layer. As you know, ISO has 7 layer. This CAN TP covers network layer and transport layer. Network layer is to interlink with the data, and transport layer is to transport the data from one node to another. Then continuity of the CAN TP is the TP can be operated with the extended addressing or normal addressing. There is two addressing in the CAN TP. One is normal addressing, another one is extended addressing. The extended addressing uses the first data byte of each frame as an additional element of an address, reducing the application payload of by 1 byte. So in this extended, it will be added additional element of the address, that is by means of first data address, which will add some other element also, that is extended. But while normal, you will not add any frame or any address. The most commonly used application is, generally TP have been useful in the diagnostic message equipped vehicle is used using KWP 2000 as well as UDS, even some OBD cases also. So that's what have been mentioned as in other specific CAN applications. So wherever the CAN have been used, so you can use the CAN TP for transferring. So that is the main application of the CAN TP in terms of KWP 2000, UDS, and OBD too. Then TP defines 4 frames. Yes, we have 4 frames in the TP, that is transfer protocol. The first frame is the single frame, that is 0. The code is 0. For the single frame, the code can be defined as 0. The single frame transferred contains the completely up to 7 bytes. That is, in one frame you can transfer 7 bytes. That is what single frame. Then the first frame contains length of full packet along with the initial data. So you have that is the first frame. You have a full package, so it will not mix up with the 4095 bytes of data. The 4095 bytes of data is nothing but for one frame means if you are start with the frame set of frame for one set of frame, that is unless consecutive frame, for one set of frame you can use 4095 data bytes can be sent. Okay, so you don't want to confuse with it. You just focus on is what is first frame and single frame, these things. Then consecutive frame, a frame containing subsequent data. That is, if you have one frame, if the frame has been filled up, then the next frame is called as subsequent frame. That is also called a consecutive frame. that is very next frame to the first frame, that is consecutive frame. The control of this consecutive frame is with flow control. So how the consecutive frame can be controlled? By using the term called flow control, that is the remaining bytes in the message contains more than 8 bytes, that is what flow control. So now flow control, the code is 3. The acknowledgement for the flow control generally is to acknowledge either ECU or either tester, to just acknowledge that I am sending more bytes, that's it. It lays down the parameters for transmission of further consecutive frames. That also, what are the parameters to be controlled, that also taken care by the flow control. So these are all the 4 frames in TP. So these are all the codes: 0 single frame, first frame 1, consecutive frame 2, and flow control 3. So this is a request and response message using flow control. See, okay, this is a client what they have gave us. Like it is in default session, so I'm not giving any diagnostic session control, as by default it will be in default session. Then 10, 17, 2E, 5C. So 10 and 17 is nothing but the PCI length, that I'll just tell you. Then 2E is a service ID, 5C is a 5C, and 66 is a data identifier. That is what client gave to write ECU serial number under this data identifier. Then from 4832C till C6 there will be ECU number. But as you are sending more bytes, so ECU want to give you flow control to ensure that you have to use consecutive frames. So ECU is to send flow control, as you are using 10 and 17, that means more than 8 bytes. So ECU can send you the flow control of 30000000. This is exactly called flow control. Okay, so what this 30000000 mean? Before that, we'll send all the data to be written. Okay, see, so this is a one frame, there is a consecutive frame. It start with 2 1. 2 is nothing but the code we know. Then 1 is a first frame, that means the to indicate that this is the first frame in the consecutive frame. Then next is 2 2. So again 2 is nothing but the code for the consecutive frame. Then again next 2 is a second frame in the consecutive frame, like that. So what, how many frames, how many datas you have, that many datas will be written by increasing by 1. Once all the data have been written, then ECU will send you the positive response of 03, that is PCI length 6E, 5C, and 66. See, okay, here I have not explained properly about 10 and 17. See, the 10 and 17 is nothing but the size of the bytes to be written. That is, we have here 30 bytes of data. The 30 bytes in the first frame, you have cleared around 7 bytes, so remaining 23 bytes of data to be written. So the 23 bytes of data to be converted into hex, that is 17. So 10 and 17, that is total data have been written. That is what 10 and 17. Then if you're not clear with 10 and 17, you can please leave a comment. I'll explain again in the comment section. Then 5C and 6 is nothing but the data identifier to be written. Then 2E is a service ID, as you are very aware, I guess. Then 30000000 is a flow control. So if you are not aware of the diagnostic session control, like I have explained, like it will be working only on default session. So please go back to my previous tutorial. I have explained about diagnostic session control very clearly, so you can just go through that, and again you can come back and watch this video. So this is what the flow control and what's the concept of CAN TP I have explained very brief manner, so you can understand in a easier way. Then we'll jump to explanation on the flow control. Okay, so see, we have seen the flow control as see 30000. So we'll look upon about this one. Flow control contains the information about flow status. So that is type 3. What is flow status? The flow status in type 3 is a fixed and followed with a different bits indicates that the transmission to be 0. 0 means continue to send, 1 means wait, 2 means abort or overflow. So that means here I am talking about, see, this one. Okay, so this one we have 30000, right? So 3 is a fixed and 0 means continued send. Instead of 0, if you give 1, it will wait, or if you give 2, it will abort. Well, the one more important thing is, what are the command you are using here, the same thing should be implemented in the source code from the developers. If developers have not implemented, and it will by default keep on send you without delay. You can change anything. Okay, you cannot able to change anything. Okay, so this is what FS, that is flow status. Type 3 is fixed and flow with the different bits indicates whether the transmission network can proceed with transmission, that is without with continue to send without any delay. One means wait, two means abort or overflow. Then second is block size. Yes, total number of frames, that message is 0 0, there is no constraint. So this is I am talking about this second one. So same in this flow control, 30 have been discussed, then 00. Okay, so this 00 means, see, the total number of frames in the message block 00 is a number, there is no constraint. The value of 0 allows the remaining frames to be sent without any flow control or delay. See, just imagine, here we have a number of data. Okay, here we have a number of frames. Okay, see, you have written this one. Okay, then for writing next frame you need flow control. Okay, then have you ever think, for next frame again you see, okay, for you got flow control, so you sent, so again you want to send another frame. Do you think you don't need any flow control for this next frame? Yes, you should think. Okay, actually this is one of the interview question. They used to ask, like, see, this is this is a first frame, single frame, sorry, this is a single frame you have sent. Okay, for in this single frame you have bytes more than 8 bytes. Okay, so you need flow control. So as soon you get flow control, you can send another frame, that is the first frame. Okay, so for first frame you got, then if you want to use second frame again, you should require flow control. That is what the logic, right? So this is an interview question. But why you don't want means, in this flow control value, that is 30 0 0 0 0, these 30 0 0 are not dummy. This tells many reason. Okay, so the first 3 and 0 I have explained. Then the second 0 0 is nothing but you can send without any consecutive frame, any flow control. You can send other frames also, other consecutive frames also. That is what this 0 0 represents. Okay, so so only without expecting of flow control you can write a number of frames and data as you declared in a PCI length. Okay, so this is what the second 0 0, that is a block size. Then next 0 0 is a time. Okay, see, so block size, it's okay, done. Then separation time, it specifies minimum time gap between the consecutive frames. So that is 0 0 is a remaining 0 0 means without any delay. If you can give 0 1 0 2 means as per the data sheet, 0 1 means how many seconds, as per data sheet 0 2 means how many seconds, that you can enter into the testing process of flow control. But again, it should be implemented in the developer's code. See,